The learning target is I can use probability to make predictions. A prediction is an educated guess. So we're going to use our probability to make a guess at what it would be if we had a bigger sample or a smaller sample. So again, probability is the ratio of the number of favorable outcomes to the total number of outcomes. So we know we have favorable over the total or the possible. So again, probability is the favorable or the desired, what we want to happen or what the problem is asking us was going to happen over the total. And we have our scale of our likelihood. Again, 0 would be impossible. 50% would be as likely as not or equally likely. And certain would be 100%. And then in between here would be unlikely. Any kind of percents in between here, and any kind of percents in between here would be likely. So if we're looking at about 15%, we know that would be in this range right here, so we would say it's unlikely. 55%, it is in between here, but it is pretty close, so we're going to say it's equally likely. It's pretty close to our 50%. And our 75% is definitely more in here, so we're going to say that that's likely to occur. So probability is a ratio, important to remember. We need the total. We cannot say that the probability is 10. The probability is 10 out of 15. The probability is 10 out of 20 because that 10 changes based on the total. If we say the probability is 10 out of 15 as a decimal or as a percent, that's going to be about 66% or 0.66 repeating. If we say the probability is 10 out of 10, that's 100% going to happen. So that probability needs that total on the bottom to tell us. And then we can use probability to make predictions using a proportion. So we can say, well, the probability was 10 out of 15 if we only did 15 trials. But what happens if we try it 300 times? How many times is it going to happen? So we can put an X up here and solve like we would solve for a proportion. So question number 1 says, Mason tossed a 3-sided cube. The results are shown below. If she only rolls the cube 12 times, what is the probability that it would land on a 2? So she landed on a 1 39 times, she landed on a 2 28 times, and she landed on a 3 33 times. So again, remember, probability is a ratio. We need the total. So I'm going to add 39 plus 28 plus 33, which will give us 100. And she wanted to land on the number 2. Well, 2 happened 28 times. So I'm going to do 28 over 100. But now she's only going to roll it 12 times. So our new total is 12 with our X on top. We don't know. And then we can cross multiply. So 100 times X would be 100X. 28 times 12 will give us 336. Divide by 100, divide by 100, and X is going to equal 3.36. So if she rolls it only 12 times, it'll land on a 2 only about 3 times, maybe 4 times, 3.6 times. A store is selling frozen yogurt. They want to use today's results to predict tomorrow's sales. If 250 customers come in tomorrow, what is the probability that they will order low-fat vanilla? Well, we still need to find the total because this is the total amount of customers for today. So the probability total today, we got to add them all up. Is 200. So 200 customers came in today. And low-fat vanilla, well, low-fat vanilla was 32. Now we're going to use that probability to predict tomorrow, which tomorrow is going to have 250 customers. Well, let's put an X to figure it out. So 200 times X gives us 200X. 32 times 250 gives us 8,000. Divide by 200. X is going to equal 40. So they're predicting 32 happened today. 42 will order it tomorrow. 40 will order it tomorrow. New York State question. It says the results for a survey of 120 students were selected at random below. 60 have a cell phone with company X, 36 have a cell phone with company Y, and 24 students don't have a cell phone. The total population of students was 380. Based on the data, what is the best approximation for the total number of students who have a cell phone with company Y? Well, let's first look at this one. 120 students, we don't have to add them up, it is our total. And we want company Y, which is 36. So this is our probability from our sample, our survey. Now we're going to use that survey, that probability, 36 over 120, to predict with a new population of 380. So that's our new total and our X. And then we can solve our proportion from there. Divide by 120 on both sides, that coefficient. And X is going to equal 114. So if there was 380 students, we would expect 114. We would predict 114 to have a cell phone with company Y. And our last day test prep, it says a spinner had 7 equal sides, 7 equal sections using to play a game. So it was used 250 times in the first game. Of the 250 times, the arrow landed on 7 a total of 35 times. So the probability of landing on a 7 was 35. That's what happened. Out of 250. That's how many times it was used. The same spinner was used 150 times in the second game. How many times did the spinner most likely land on that section? Well, we're going to use this probability, 35 over 250. But now our new total is only 150. How many times did it land on a 7? So 250 times X gives me 250X. 35 times 150 gives us 5,250. Divide by 250. And we're going to say X equals 21 times. So instead of 35 times out of 250, only landing on that 7 21 times out of 150.